So we will continue from do while repetition. Actually, this do while is very similar with the while repetition statement. What is the difference in the while? How it is working? As you know, we have a while loop, while like this. So let's say we have a control statement for the termination. Then you do here some actions, increase the counter. And of course, in the beginning, it's same for all the loops. You need to have one initial condition. So how this is working? First, you initialize it, check the condition. You are doing some actions. I don't know, addition, multiplication, printf, whatever it is. Then increase your counter. This is of course control loops, counter control loops. Increase the counter. In each iteration, check the condition again. If it is true, do the statement. When it is false, exit from the while loop. In general, it is like this. So first, we are checking the condition, then doing the action if it is true. So how the do while is working? It's the inverse. We write do some actions here. While
There's nothing really hard for you.
Okay. And then we need to put semicolon here. So how the do while is working, you can understand from the name. First, do the statement while the condition is true. So in the while, first you are checking the condition, then doing the action. In the do while, it's the inverse operation. So you are first doing the action, then checking the condition. But of course, they are not very different from each other. Mostly what you can do with the while, you can direct translate it to do while and do the same action. Just the operation order is different. Here we are first checking, but in this one, first you are doing the action. After you finish the action, you are checking the condition. So similar to the while structure, condition for repetition only tested after the body of the loop is performed. So first you do the loop, then
doctor,
yes,
it will do the instruction and then it will check the while. Okay, if the while is false, it's 0. It will cancel the do.
No, you will do it because you are doing it, right? Then checking the condition. You will do it. If it is false, you will exit here. From here, you will exit. But before this action, you will do it. Okay?
Also, you will make counter is equal to 0. So that and not equal
of
to
course, of course. This is the same. Here you have some initialization, and here you will, of course, again increase it. Okay?
Yeah, okay.
Just the order is different, and most actually I am not using do while. I am using while because I can do everything what I can do with the do while. I don't know, maybe if there are some exceptions that you cannot do, like if you want to do some structure before the checking condition, but mostly you can do everything during the using the while as well. All actions are performed at least once, because in the do you are doing it before checking the condition. So in the while, even you can, because in the while, for example, this is also different. In the while, first you check the condition. So it is also possible that you will not enter to the loop. From here, for example, if I initialize this one as 11, what will happen? This is 11. This is false, so I will not even enter the while loop. But in this one, if you even check it, as your friend asked as well, if you even set this one to 11, what will happen? First, you will do this action, then check the condition. So it is for sure that you are going to do the first action. At least you will do once the loop. That's why it's saying that all actions performed at least once. Because in any scenario, you are going to execute the do before checking the condition. And this is the format. So do, you open the braces, the statement, the action that you are going to do. You will close the braces, write the while, and don't forget, here you need to put the semicolon. Otherwise, it might go to infinite loop or something like this. So this is the format that you should obey. Here we have an example. So what we are doing here, we did the similar example with the while as well. So do printf the counter, and we set the counter to 1. We initialize as 1. So what we will, and then here in the while, you know what does this mean? First increase the counter and check the condition. Or you can write this one. And this is 1. Or you can write this one. What does it mean? Increase the counter and then check the condition because it's pre-increment. Or you can increase the counter here. It's the same operation. Counter plus plus. You remove this one here. So it's the same action because first you are increasing the counter, then checking the condition. So what we are expecting here.
Doctor, is there a do if?
Do if.
Yeah, instead of while we use not if. Sorry, for.
No. This is special for the while. Do while. This is like a template. You should learn it like this. Okay. So here what we are expecting. First, we are doing the printf action, which is the counter. Increase it 1 by 1 and check the condition if it is less than 10. And how you can write this one as well in the while. Again, you say counter is equal to 1 while less or equal to 10. Printf the counter plus plus. So these two actions are exactly the same. Because in this example, it doesn't matter if you are checking the condition at the end or in the beginning. In this one, we are checking in the start of the loop. In do while, we are checking the condition at the end. So what will happen here? Let me also do the output for you. And so we initialize the counter as 1. We are entering the do. There is no checking condition in the beginning. So do printf the counter. What is the counter? It is 1. Then give some space because we printed it like that. We give the space. Increase the counter by 1. So what will happen? Counter will become 2 in this condition, in this statement. After that, we are going to check the condition. 2 is less than that. It is true. Then again, go to the back to this statement. So then 2. When you print it, give 1 space, increase the counter by 1. Counter will be 3. Check the condition. It is again true. 3 is less than 10. Again, go back and print the counter. So just the order is different. But in here, what we are doing, counter is 1. So this will continue up to 10. So basically, it is printing 1 to 10. In this one, what's going on? So again, counter is equal to 1. We check the condition. It is true. Print it on the screen. 1. So count, then increase the counter. Counter will become 2. Go back, check the condition. 2 is less than 10. The condition is true. Print the value. Again, increase the counter by 1. Counter will be 3. We check the condition. It is true. We print it on the screen. Is there any question about do while? Or
No.
did you understand like what is the difference between while and do while? Actually, it is just the order of the checking condition is different. That's it. And you can do everything with while as well. Some programs always include braces in a do-while statement, even if the braces are not necessary. This helps eliminate ambiguity between the do-while statement containing one statement and the while statement. So in here, always put these braces. So you will understand that it's a do-while. Because if you don't put this, you know, in general how it is. If you have just one like this, if you have just one statement, printf, you don't need to put braces. This is a general rule. You can apply this one in if, in while, in for, in each condition. But in do while, not necessary, it's not syntax error, but put these braces so you will understand that this is a do while structure. Infinite loops are caused when the loop continuation condition in a while, for, or do while statement never becomes false. You know, when the condition never becomes false, it's an infinite loop. You will never exit from the loop. For example, here, while counter is less than, if you say is greater than 0 and start the counter from 1, what will happen? This counter value will be always greater than 0. So this will be an infinite loop. It will never terminate. This condition will be never false. So you will enter, the program will enter to infinite loop. So that's why I also warned you before, you should be careful about your termination condition and the initial point. To prevent this, make sure that there is not a semicolon immediately after the header of a while or for statement. For example, here, if you do like this, again, it's false. You know, we will not put semicolon after the while. Or if you have for loop like that, we don't put semicolon just after the for loop. We do the braces and so on. In a counter control loop, this was the example that we gave as well. You know, what is counter control loop? You have one condition and an increment at the end. Make sure the control variable is incremented or decremented in the loop. Here you see we have one condition. Then at the end we are increasing it or decreasing it. But if you don't put this line, what will happen again? This initial value will be stayed there and 1 will be always less than 10. So it will be again an infinite loop. That's why in counter control loop, we should always increase or decrease. In a sentinel control loop, make sure the sentinel value is eventually input. What is sentinel control loop? We did it before. For example, we did one example. Grade is not equal to -1. So at the end, the user should enter -1. Otherwise, again, it will be an infinite loop. Or this input should be available to the user. We did this example. As you know, this do while will print the values from 1 to 10 with a space because we put a space inside the printer. If you want to put them, you know, in a new line, then you are going to put here instead of the space /n like this. Okay. This time it will be printed like this, horizontal, vertically. And this is flow chart of the do while. So first, you see, whatever it is, we are doing the action. Then checking the condition. If the condition is true, again, we go back to so this is the do part, and this is the while part. If the condition is true, do the action inside the do, and this is the condition inside the while. Until the condition is false, we will repeat this loop. Is there any question? Let's check some more examples here. This is example 2. PDF that I upload also to our website. We did this once. Just here because do while is here. I will do the do while. Sorry, I think I disconnected. Okay, this is example 2. And do while examples are here. That's why I come to example 2 again. We did this one before. While examples are here as well.
Excuse me, sir, I have a question.
Yes.
When I have to write int main void, when I have to just write int main
Sorry.
at the first,
Yes.
when I have to write int main,
Here.
and
Yes.
when I have to write int main void.
Like this.
Yes. What's the difference, I mean?
The difference, like in the next chapter, we are going to enter the functions, and there are 2 types of functions. Actually, this int main is, you see also here, it's written function main begins. It's actually a function, the main function that we are writing our code. So there are 2 types of functions. One with a return type function that you return a value, an integer value, a float value, or whatever. So if you write int main, then you need to write return 0 as well. You need to return a value. But if you write void main or int main void, then we are not going to return any value. So you will just remove this return part. This is the difference. But rather than that, there is no difference. Okay?
Okay, thank you.
In the functions next chapter, we will see like what these types, so you will understand better why we are using void, why we are using int, and so on. Also, there is functions with float, not just int main. Int main, we are using it int main, but also there are functions that double, float, and everything. Okay, so let's example from here. We already see that the flow chart. This is a sentinel loop. As you see, program to add numbers until user enters 0. We did before with -1. Here we are doing with 0. So if the user entered 0, then the loop will terminate. Let me copy this one. So we enter numbers 69, 76, 64, 32, and when I enter 0, the loop will terminate and we will add these 4 numbers. We did this before with while, with for. So in general, as you see how it is working, first do the action. So we are asking to the user to enter a number. Then by using sum plus is equal to number, what does this mean? You know, sum is equal to sum plus number. So each iteration, we are adding the numbers. Start, of course, you need to initialize sum as 0. So in each iteration, we are adding the numbers. And after each do operation, we are checking the condition while number is not equal to 0, because this is a sentinel control loop. And when the user enters 0, the loop will finish. And if the loop is finished, the next operation is printf. We are printing the sum value on the screen. Is that clear? And how we were doing it before? If you want to do this one with while loop, how you are going to do it? While number is not equal to 0.0. You ask the user, you add numbers. Just what is the difference? Before entering the while, because it's not do while, again here you need to ask the user to enter the value, to check the condition. Printf, enter like this one, enter a number. Because before entering the loop, we should check the condition first. But in the do while, you don't need it because first you do the action, then check the condition. Enter a number, 89, 75, 54. If I enter 0, the loop will finish. We will add these 4 numbers. But I think there is a problem. I think we are not adding the first number. 1 minute. Why is that? Okay. We should get this one to here. Because before asking the question, we need to add the first number. We are getting the number here. We check the condition. We will add it, then ask the question again. Now it is okay. But in the do while, how was it? Let me show you. Okay. So in the do while, you can see the difference here clearly. First here, we need to enter the number. You see, we are asking to the user. Check the condition for the first one, then add the numbers and ask the question again. So for each iteration, we are adding the numbers. And let's see how it is working in the do while. You can directly take the number from the user because at the end we are checking the condition. So in the do, we are asking the user, entering the numbers, adding them up, and at the end, we are checking the condition. So you don't need to ask it before the do, because inside the do, we are doing the first action before checking the condition. But in this one, first we are checking the condition. So before the while, you need to enter a number to be sure that it is not equal to 0. Is that clear?
Yeah.
Okay.
So the double, you said it represents what again?
Sorry?
The double, where we said line 5.
Line 5. A double is a float, but with more precise. So you can show more floating points. That's why we are using double. So in the float, let's say you can show 5 digits after the floating point, but double you can show more, okay?
All right, so thank you.
Like long integer we saw before, integer and long integer. With double, with the float, you can keep 32 bits, but with the double, you can keep 64 bits. This is the difference. So it's more precise. Okay, let's do another example here. Okay, this is the same example, sentinel value example with while. We did this one before. While grade is not equal to -1, add them up, blah, blah. Then calculate the average. We did exactly same example.
Excuse me, sir.
Yes.
Can we use these? Do we have access to them, the PDFs?
Yes, you have. On the
Alright, and
Moodle, you
this-
have.
All right, thank you.
This is, for example, example 2 PDF. You can see it on the Moodle.
Okay.
Okay, here we have another example to find the minimum and maximum value. So we will have a loop. In this example, it is do while, but you can do the same, repeat the same example. I can show you with the while and for loop as well. This is a general form how to find minimum and maximum value. So we will enter some values. For in this case, we will enter values until we press -1 to quit. So we will enter some values and the program will give us the maximum value and the minimum value. And this is the easiest way and very general way to find the minimum and maximum values. Okay, let's do one example, then I will explain the details. So let's say we enter 20 minus 65, and they are double float or okay, they are integer numbers, so I'm just entering integer numbers, but you can modify the code, make them all float numbers as well. 100, 200, minus 900. Okay, I entered some random numbers. Then, if I press -1, the loop will terminate and will give me the minimum and maximum values. I press -1. So the maximum value is 500, as you can see here. The maximum number is 500. And what is the minimum number? It is -900. Okay, let's check how this code is working. And keep in your mind, when we are finding the minimum or maximum values, for the maximum value, you should initialize them first, the max and min. This is to detect the maximum, and this min is to detect the minimum value, like total to add the numbers. So you should first initialize them. For the maximum number, you should initialize them with a very low value. I mean, for this case, we selected -99999. Select the lowest value possible, okay? For the max, so it is the inverse. For the max, we are selecting the lowest value possible. For example, if this is a grading example, what I am going to select for the maximum, if I am going to calculate the maximum grade, or if I'm going to find the minimum grade. What, in this case, what will be the maximum value possible for grading? What is it? No idea.
0.
Yes. What is the lowest value for grading? What is the range for grading? It is 0 to 100, right? So what is the lowest value possible? It is 0. Then for the minimum, then the inverse operation. Select the highest value possible. This is a general example. That's why we are selecting a very huge number, 9999, whatever. But if it was a grading example, then 100 is enough because 100 is the highest possible value. And let's do grading example, doesn't matter. Then I will also do the general one. Okay, let's say this is an example that the user will enter the grades and the program will give us an output, the minimum grade and the maximum grade of a class. So for the maximum, we selected the lowest value possible, which is 0 for the grading, and for the minimum, 100. which is the highest possible value. Then we have a do. First, we are taking the number or grade from the user until we press -1. And why we are selecting the initial points like that? What is the logic behind it? Because we want the first number, we want to be sure that the first number the user entered will be greater than this one. So we will update the maximum value, and will be lower than this one. So we will update the mean value. For example, let me copy this part for you in detail. You will get the idea. Okay. First, we initialize these values. Then we will go to the do, printf, enter a number. Let's say in the first loop, the user entered number is equal to 65. Then what I told you, we are going to update the max value. So that's why we selected as the lowest possible. So the first value entered from the user, it will be for sure higher than the max, this initial value. So we will update our max value. So each iteration, whenever a number entered higher than the maximum value, we will update it as maximum value. So for example, after 65, if the user entered 85, we will update the maximum value as 85. If 100, then 100. If no values entered higher than this value, then it will keep as maximum value. So let's see in the iteration how it is working. So let's say the user enters 65. First, we are checking the condition. If number is greater than max. In the first iteration, as I told you, for sure it will be higher than, that's why we are selecting as minimum possible, lowest possible. Because in the first iteration, we need to update it. So number is 65. It is of course higher than 0. If number is higher than max, update the maximum value. So the maximum value will be updated as 65. Then check for the minimum. If number is less than minimum, and the same scenario, we want to be sure that the first entered value will be less than the mean. So for the grading, for sure the first value will be less, and of course you can select this one max equal to also counting this if the user entered 100 and 0. Then we will check this condition. Number is less or equal to mean. What is mean? It is 100. The first value, of course, will be less than or equal to 100. So we will update the mean value. We have just now one value now. So the mean and max, of course, is the same. And this one just to check -1 condition. If it is -1, we will directly exit from the loop. Okay, then on the second iteration, we check the condition. 65, 65 is not equal to -1. So we go back again, ask the user. Let's say the user entered 85. So this time, again, this will be true. This is number. Because number is 85. What is the maximum value? It was updated as 65. So 85 is greater than 65. The condition is true. We are going to update the maximum value as 85. So whenever a value came bigger than your maximum value, you will update it. If no value entered bigger than your value, it will stay as max. That's it. And for minimum, the number is 85. 85. What was the minimum value? It was 65. It is not less than 65. So this condition will be false. So minimum value will stay as same. So minimum is 65. And it is true, you see. Max, we entered just two values, 85 and 65. Max is 85, min is 65. Then again, we check the condition. It is not false. It is not equal to -1. Go back to the do. Again, ask the user. Take one number from the user. Let's say it is 42. What will happen? We check this condition. The maximum was 85. So 42 is not greater than 85. Max will stay the same because this condition will be false. We will skip the update part. We will skip this one. So max is still 85. Then we will check this condition if number is less than min. What was the min value? It was 65. We entered 42. 42 is less than 65. So this condition is true. Minimum number will be updated as number. So minimum number will be updated as 42. Let's do one more example. Or let's finish. I think it is clear. Let's say the user entered number is equal to -1. We will check this one. It is not true. This one, because this is the condition, number is not equal to -1. So this condition again we will skip. We will come to this point. File number not is equal to -1. This condition will be false. So we will exit from the loop. So at the end, the maximum value will be updated as 85 and the minimum value will be updated as 42. But if you again take a number less than 42, the minimum value will be updated. Or if you take a number greater than 85, the maximum value will be updated. This is the logic. Is that clear? And for our case, it was like this, 99999, a very low number and very high number. So for sure, the user will enter greater than this value. So you will update the max, and inside the loop, this will goes on. Whenever a greater value entered from the user, the maximum value will be updated. And for sure, the first value the user entered will be less than this value. So, and you will start the loop. After that, you will check if there is a less number than your minimum value. If the user entered a lower value, then you will update the minimum. And this is a very general form how to detect max and min. Even in the functions, we are going to see it. This is what we are going to do. How we can write this example using for loop. Or let's first do it while. So while number is not equal to -1, first we need to take it from the user here. Then we will check the condition. Update the max, min, and ask the user again. So if directly enter -1, we are not going to enter the while loop. But if another number entered, we will enter the while loop, check this condition, update the max and min inside the loop. Whenever you update the max or min, then you will ask the user again to take the value. Clear?
Yep.
Okay, let's continue. Do we have another example? Okay, switch, we did it before, so that's enough for the do while. Break and continue statements, we did them before actually. For the break, what was the break doing? Inside the loop or switch?
To stop the case.
Exactly. It will it will stop the loop or the switch. So causes immediate exit from a while, for, do while, or switch statement. When the break came, the program will exit from the loop. whatever it is. Program execution continues with the first statement after the structure. So if you have here, you know, a for loop, we did this one before, 1, then what, let's say we write so what we are expecting here, we did this example before. When the I is equal to 5, we will exit from the loop. So the output will be, we will write I is equal to 1, 2, 3, 4. Then we will also write 5. After that, we will check the condition. If I is equal to 5, yes, it's true, break, exit from the for loop. So we will exit from this loop before waiting for the termination, because break appears. So we will exit from the loop, go to the next action. So we will exit. Yes.
What will happen if we write if I equal just one equal, not two?
Like this. So this means, I told you before. So inside this if will be always true, because this means I is equal to 5. So inside the if will be 5. Okay. So what does it mean? This means this condition is always true, because non-zero elements inside the if means true. So whatever you did, this condition will be true. That's why inside the if you should avoid it and write it equal. Okay.
Okay, I got it.
In this one, it just means if it is equal to 5. But in this one, it's just set the I equal to 5. This is the difference. So keep in your mind, write equal. And then common uses of the break statement: escape early from a loop, like this one, you see. Before waiting I to reach 10, we write if I is equal to 5, break. So when I becomes 5, we are exiting from the loop before waiting the termination. Skip the reminder of switch statement. You know, switch, how we were using it. Switch case. We do some actions. And then I told you write break. Because if you write break, what does it mean? Check the case 1. If it is true, do these actions and exit from the switch. If you don't write break, what will happen? It will also going to check all the rest cases, case 2, case 3, case 4, and everything. So the execution time will be higher. That's why we always write break. So if one condition is true, we don't need to check the rest, like if else. When the if is true, you don't check the else if condition. So the same idea. If the case 1 is true, don't check the rest. To speed up your execution. Okay, we did this example. When x is 5, break, so exit from the loop. There is another one, like the break, continue. So what continue does? Skips the remaining statements in the body of while for or do while statement. So it will skip the iteration. So if you write here instead of break, continue. Any idea what might be the output?
From 1 to 10.
Sorry.
From 1 to 10.
It will be like this. What will happen here?
I think it will skip 5, it's right? 1, 4, 6, 10, up to 10.
It will skip 6 because after that we will, but if you do like this, it will skip 5 as well. If you do like that. So when 5 appears, when I is equal to 5, continue. This means when I is equal to 5, skip to the next iteration. Skip the 5 and start from I is equal to 6. So what will happen? We will skip the 5. We will continue from 6. Clear? So you will just skip the iteration. For this case, we are skipping the I is equal to 5 condition.
Sir, it's like whenever we have a continue, it always skips the condition inside if.
Yes, like continue. So we use it with if. So if I is equal to 5, skip it. So in this case, when I becomes 5, we go to the next iteration. We will not do the action there.
So we can
And
say
for
it
the break,
jumps.
Sorry.
We can say it jumps from.
Exactly. Skips,
That-
jumps. But we will not do the I is equal to 5. We will jump to directly I is equal to 6. That's why
that's for the continue, but for the break, it stops till 5.
Yes, in break you exit from the loop. It stops. But for continue, you skip.
Okay, thank you.
But loop proceeds with the next iteration of the loop. For this case, we set 5, so we proceed to 6. We will not do the action at 5. On the break, we will exit at 5. We will stop the loop. This is the difference. While and do while loop continuation test is evaluated immediately after the continue statement is executed. So if you write continue, directly you go to check the termination. For example, like if this was while, something like this. Or let's put this one here. So what will happen? Whenever this is true, continue. So you will skip this rest action. Again, you go back and check the condition. So basically, you go to the next iteration. Increment expression is executed. Then loop continuation test is evaluated. So you increase it. Sorry. When this is true, what will happen? You skip. You will go to here again. You increase it and check the condition. So basically, you go to the next iteration again. You increase the counter or the I value and go to the next iteration. Okay, here as you can see, 1, 2, 3, 4, because x is equal to 5, we skip the 5, we directly continue from 6. So we proceed to the next iteration. Okay, our last topic in this chapter, logical operators. We already see AND and OR actually, I showed you before. What is AND means? Returns true if both conditions are true, like this one. AND is like, multiplication. You can consider this non-zeros as 1. So in logic, how it is, 0 and 0, it is 0, 0, 1, or non-zero, it is again 0. So the both conditions should be true, then the output will be true. If one of them is false, the output will be false. 0 means false. So false, false, it is false. False, true, it is false. True, false, false. When the both conditions are true, or 1, 1, true, true, it is true. And in the OR, So you can consider AND as multiplication. So you know 0 multiply something is 0. 1 multiply 1 is 1. And or as addition. So 0 plus 0, 0. So false, false, false. 0 plus 1, 1. So if one condition is true, in the OR, it is true. But in the AND, the both conditions should be true. So false, true, true. True, false, true, 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 true. I will give you one example. What is not? We did it before. 0 not is 1 and non-zero not is 0. So false. If you do false not, it is true, and true not, it is false. So if I want to show this one, how I can show it? 20, number 60. If I want to show this range inside an if, how I can show it? Any idea? No idea. It will be AND or. AND, right? Because the both conditions should be true. It should be greater than 20 and less than 60. The both conditions should be true. So number is greater than 20 and don't forget, we are not going to write just one AND. This is for the scanf, if you remember. So if you want to use it as a logical operator, you should use it as and, like equal. Number is less than 60. So what does it mean? These two conditions should be true. If number is greater than 20, for example, if you say 35, 45, this condition is true and this condition is true. So the inside of if will be 1. So the statement will be executed.
Sir?
Yes.
There's in the meeting chat, Solane said that she has to leave for a hospital appointment or something like that. Can you check? Like she's asking for permission to leave.
Okay. It's okay. It's okay, Solana, you can leave. I will note you on the attendance. No problem. Okay. And the last thing that you also asked me, confusing equality and assignment operators. Does not ordinarily cause syntax errors. If you write inside the if equal or equal, like we call it equality, and this one assignment, will not cause you a syntax error, but it's a logical error. An expression that produces a value can be used in control structures. Inside this one, we mean non-zero values are true, 0 values are false. We said it before. So if you write it like this, what does it mean? If the pay code is equal to 4, this condition will be true. Otherwise, it will be false. Checks pay code. If it is 4, then the bonus is awarded. Let's check this one. But if you write it like this, pay code is 4. So what does it mean? This is always non-zero. Pay code is set to the 4. So this condition will be always true. So whatever the pay code it is before this if statement, the condition will be true. So it will be always the bonus awarded no matter what the pay code was. So this is the difference. Be careful inside the if, use equality, not the assignment. Otherwise, if you use assignment, this if statement will be stayed always true. Logic error, it's not a syntax error as I told you. Using equality for assignment or using operator for equality is a logical error. Also, to write like this, it's a logical error. And the last thing, I told you before as well, we are assigning the values, this is assignment, from right to left. So you cannot write 4 is equal to x. This is error. You should write x is equal to 4. You will assign 4 to the x. Or same like this. You cannot write a plus b is equal to c. You should write c is equal to a plus b. So what's happening here? We will do first this action, a plus b, and assign it to the c. Otherwise, again, you will get an error. Yes.
If I want to like to initialize like 7 values, if when I did it in the DFC, I just make a test. Some values had random values like 37 or 1. I didn't give any value. I didn't give any value.
But how you write like integer a like this?
I write integer a, comma b, comma c, comma d, comma e, comma f like this.
Okay, and write 0.
I tried without writing 0, and I tried with writing 0, but every time I get some random numbers. Like all of them will be 0, but D will be 27.
Interesting. Did you try it like this? Int a, int b?
So I use this the other way, but I'm asking if I can do it in single line or not.
Yes, you can do it. Let me try.
What is the correct way for the single line?
1 minute. Let's try.
Sorry, teacher.
Yes.
Sorry, teacher.
Yes, I'm listening.
Yes, I have an appointment. The time is past. I sent you a message, but you didn't reply. Please, can I leave the class?
Yes, I said yes, you can leave. I wrote also to the chat.
Sorry?
Yes, you can leave.
Thank you, sir.
It's okay. Then we are going to print. Right, like this, right?
See, a equals 1 here.
So when I was doing the lab 2, I forgot to assign it to 0. So it's the same. It just gives random numbers, and the
Then
assistant said,
assign it like this, okay? Clear? Don't just assign the last number. Assign them like that. If you have this kind of problem.
Okay, thank you, sir.
As I remember, it is correct to do like you said, but I don't know. Just initialize them in each separation point, okay? Okay, that's it. This is the end of the chapter. Let's do a couple of more examples with the for loop. Then I am going to finish. Now I will do some examples. So let me do first here the examples. What is this one? We did this one. Okay, this is break. This is continue. And this is exercise 4.3 from the book. Actually, the code was given and the question asking you what is the output. Let's Okay, let's first show you how it is working, then I will also run you the code. Okay, we started x from 1. X is less than or equal to 20. Increment. Then we print the x value. If x, what does it mean? If x modulo 5 is equal to 0, go to the new line. So when x is divisible by 5, go to the new line. What does it mean? We start from 1. So after every 5, we will go to the new line. Basically 1, 2, 3, 4, 5. 5 is divisible, go to the new line. So start 6 from the new line. Then 6, 7, 8, 9, 10. Again, go to the new line. 10 is divisible by 5, so go to the new line. Let's do it inside the loop. In the first iteration, as you know, we set x is equal to 1. We start from x is equal to 1. Printf the x value, and here I will show you the output. Printf the x value. What is the x value? It is 1. So we printed 1. Then we will check the modulo 5. 1 modulo 5, it is 1, not equal to 0. This is false. As I told you, we are just checking if it is divisible by 5. 1 is not divisible by 5. This is false. Then we will go to the else condition, printf /t. What is /t means? Give a space with tab. Then increase the x value by 1. Then x will be 2. We will print the x on the screen, 2. Again, we check the condition. It is false. It is not divisible by 5. We go to the else, printf tab. So if it is not divisible by 5, we are giving tab, giving space. If it is divisible by 5, we are going to the new line. Then we increase the x by 1. X is equal to 3. We check the condition. It is true. We print the x value on the screen. This condition will be false. 3 is not divisible by 5. We go to the else, give tab. Then x is 4. The condition is true. We print it. 4. This is false. We go to the else, give tab. Okay, in here, what will happen? X is equal to 5. The condition is still true. We print the x value. Then we check the if condition. 5 modulo 5 is equal to 0. 5 is divisible by 5. So this condition is true. Printf /n. So go to the new line. So we will continue from here. Instead of tab, this time we go to the new line. After that, again, we will do the same. X is equal to 6. You know this is true. We print the x value on the screen. This condition will be false because 6 is not divisible. Else, printf tab. And this will continue like that. 8, 9, 10. Then when x is equal to 10, what will happen? This will be true because 10 modulo 5 is equal to 0. 10 is divisible by 5. Printf /n. Go to the new line. And again, continue from 11, 12, 13, 14. Then when a number appears divisible by 5, which is 15, go to the new line. 16, 17, 18, 19. And you know, the last iteration is 20. And at 20, finish. Because after that, you will increase the x value. It will be 21. And this condition will be false. So this will goes up to 20. X will be 20. After that, when you increase the x value, this condition will be false. So you will not enter the for loop. The for loop will end. Is there any question?
Do we need to initialize x value for loops, or is it enough to put x inside the for?
Or you should write like this. You need to, of course, initialize. Or you can write like that.
Oh,
Okay?
okay.
So in some point before the for loop, you need to initialize it. Or inside the for loop, does not matter. Like in the loops, it's always the condition. You need to initialize it. Okay, the next example. Okay, before starting this one, you know, until now, we just see the loops with one loop. For example, one for loop. There is no tail loop inside this for loop. We call them nested loops. Now we are going to see a couple of examples with nested loops. So a loop inside a loop, like this. Until now, we just see for loop. We do some actions. There are also nested loops. So a loop inside the loop, or maybe another loop inside the loop. 3 loops together, like this. For let's say 1. And inside this for loop, another loop. You write it like this to don't confuse. And you do some actions here. After that, you need to close the both braces. Don't forget, whenever you open a braces, then you need to close it. Otherwise, you will get a syntax error. So how these loops are working? This is very critical. So how they are working? First, you will start from this loop. You will start from I is equal to 1. After that, we are going to finish all the second loop, because this loop is inside this one. So first, you start from 1, then we are going to finish j up to 20. When this loop is finished, we will update the I value again. So it will be like this. 1, then I will stay 1 up to when j is equal to 19. What will happen? This loop will be over. The first loop will be over. Or we call this one outer loop, or I can call it first loop, whatever. And this one inner loop. So first you are going to finish the inner loop. When the inner loop is finished, you will update the outer loop again. So you see I is equal to 1. We finish all the j values, this one. When we finish it, after that you can update the I value again. Then we will do the same process for I is equal to 2. You start from 1 up to again j is equal to 19. So what is the difference? You can consider this one as a single dimension. We have just one dimension. If it is if you think about linear algebra, then this is a vector. We have just one dimension. We do it like this. But in this one, we have 2 dimensions. Let's say this is for rows and this is for columns. So you can even write like that. Whatever. Just an example. So you can think them like this is like to form a vector, you just need one dimension. But to form a matrix, then you need to have 2 dimensions. And in some operations, you need to have 2 dimensions. And this is the idea how it is working. Start from the initial condition of the outer loop. First, finish the inner loop. When you finish all the iterations in the inner loop, update the outer loop again until you reach I is less than 20. Is there any question?
Can we see a code doing this?
Yes, I will. Let me first show you this one. Okay, here I have an example. I set them to 5 and this j to the 5. Mostly this is how we are defining the nested loops or double loops. We can save this for this one. The first one, we call it I, and the second one as j. This is a very general form. You will see it. This is the row numbers and this is the column numbers, I and j. This is very general form. But of course, you can also define it as counter 1, counter 2. So what will happen here? This is the same example that I showed you. So I start from 1 up to 5. J starts from 1 up to 5. And we are going to print these values, the I value and j value. Why I am doing this example? To show you this one. As I told you first, I will stay 1, 1, 1, 1. Finish the j. After that, update the I value. So here what I am expecting, I will be 1, j will be 1. Like it will be like that, right? I will be 1, j will be 1. Then slash n. So let's do like. Then I will be 2, 1. You will update the j value, 2. I will stay until j values finish, I will be the same. When the j values will finish, j is less than or equal to 5. When j reach to 5, the inner loop will finish, you will update the I value. J is equal to 4. Then what will happen? J is equal to 5. Now the inner loop is finished. You know, I told you this is the inner loop. First finish the inner loop, then update the outer loop. Then once the inner loop is finished, when we reach to j is equal to 5, we will update the I value and start the inner loop from the beginning, from 1. And this will goes like that. Now j2 up to what is the termination for I? Less or equal to 5. So when we reach I is equal to 5, j is equal to 5, the loops will finish. The both loops will finish. So whenever you update the I value, the j value will start from the beginning. You should keep in your mind. Let me show you. So this is in the output, we need to see that. This is an example to show you how the loops are working. Oh, sorry, we need to close it here. You see? First, the outer loop, I is equal to 1. We finish all the j values, I1, j5. This is the first iteration in the outer loop. Then we update the I value. Again, j will start from 1 up to 5. After that, update the I value. Again, j 1 to 5. When j reach to 5, we update the I value. And when it will finish, when both conditions are satisfied, I is equal to 5, j is equal to 5. Both inner and outer loops will be terminated and we will exit from the loop. Is there any question?
Sir, what will happen if you write the printf after the inner loop?
Here,
After the inner loop, not
it,
the
it,
outer loop.
it is inside the inner loop. This is inside the inner loop.
So if you write the printf after
Look,
you the inner
look,
loop.
this is for loop, the outer loop, okay?
Yes.
We open it, then we put another loop inside this one, and we open this one. So what does it mean? This printf is inside also the inner loop, both loops. Okay?
Okay, I understand. Thank you.
Doctor, is this in the test on Friday?
It might be, yes. This will be included. But I don't know, maybe we will not ask you nested loops. I haven't decided yet. I will tell you on Wednesday, okay? Let's continue. Okay, here we have an example. We will take two values from the user, range from 1 to 20. We call them X and Y. And here you will understand why I am saying the first one, the row number, and the second one, the column number. And then we will print some stars. Actually, this is same as, also you can close this one. Oh, sorry. Was here, sorry. Okay, let me show you what will happen. 4 and 5. So it will print you with stars 4 by 5, a rectangle. So the 4 indicates the column number 1, 2, 3, 4, and 5 indicates the row number 1, 2, 3, 4, and 5. Okay, the first one, the Y value, or let's do Y, I don't know, it's like, let's do like this. So the first number that I will enter will be the row number, the second will be the column number. So the first loop will control the row numbers, and the second loop will control the column numbers. So if I enter 4, 6, so 4 rows, you see 1, 2, 3, 4. I told you the first loop will control the row numbers, X is the row numbers, and 6, 1, 2, 3, 4, 5, 6 is the column number. So 6, and the second loop will control the column numbers. And let's see how this loop is working. Actually, it's quite easy when you understand it. So this X and Y values will be taken from the user. Let's say the user entered 2 and 3. So what we are expecting, 2 by 3, a rectangle. The row number 2, column number 3. We are expecting such an output. Right? 2 rows, 3 columns. And let's see now in each iteration how it is working. Of course, we will start from I is equal to 1, X is equal to 2. So I will write here 2 and 3. When I is equal to 1, this condition is true. We will enter to the second loop. Then we will set J is equal to 1, right? J is equal to 1. We will check this condition. It is also true. We will enter to printf. So on the screen, we are going to print a star. After that, as we did before, I is still 1. First, we should finish this inner loop. J will be increased as 2. This condition is still true. Printf star. So we will print a star. Again, the same until j, the inner loop, will terminate. Then we will update j value as 3. This is our last iteration. It is still true because less or equal to 3. We will execute the statement, which is
Excuse me, sir.
yes.
Isn't it better for us if we pushed the second loop like 5 spaces further to the right? Because it will be easier to follow.
Which one?
Like if we put tab before the second loop and the function of it, printf.
Like this?
Yes, because it's easier to follow like this, I think.
Okay.
I believe.
Okay. Okay, now we are here. We put 3 stars. J, this is the end, because after that, J will be 4 and this condition will be false. So we will exit from the inner loop. After that, when you exit from this one, what is the next action? Next action, printf /n. So go to the new line. We will go to the new line. Again, we will increase the I value because everything inside this outer loop is finished. We are going to increase the I value. So I will be equal to 2. Again, we will start from the beginning to the j values, to the inner loop. So we will start from j is equal to 1. Printf star. We will start from here again, printf star. After that, I is still 2. J is equal to 2. We will print another star. Then I2, J is equal to 3. This is the last iteration for the inner loop. J is equal to 3. This condition is still true. We will print a star. After that, this one is finished because J is 3. This is the last iteration inside the inner loop. This is finished. So you will go to the next action, which is /n. You go to the new line. But as you know, I is 2. So what does it mean? After this one, this loop will be terminated as well. So the both loops are finished. When I reach 2 and J reach 3, this is the end of the both loops. So this nested for loops finish. So on the screen, what we are seeing, a pattern with the asterisk with 2 rows and 3 columns because we entered 2 and 3. If you entered 4, 6, then you are going to see 4 rows, 6 columns. Is that clear?
Yes, sir.
Okay, I hope it is clear. Just now keep in your, we will do a couple of more examples. These are the basic ones. As I showed you, first you start from this one. You entered you entered one by one. In each iteration for the outer loop, for the I value, you need to finish first this one, the inner loop. After that, you can update this I value. This is like iteratively I showed you each step. And on the Wednesday course, we will go a bit further. We will do some more advanced examples. Today, what we did, just I show you how the nested loops are working. One example, this is like, printing a rectangle or square. Then on the Wednesday course, we are going to see some examples to print triangles or diamonds. Like this, I can show you here. You see a right triangle like that using a nested loops, or inverse right triangle like this, directly a triangle like that. Again, we are entering the rows and printing triangles, and a diamond shape. And of course, these are more advanced. Okay, if you don't have any question, I want to take the attendance and let you leave. Please stay present if you are here. Davut Demirol. Not present. Ervan Urkaya.
Present.
Hasan Salah. Not present. Barış Yeral. Barış.
Yes, sir.
Okay. Mustafa Toslak.
Here, sir.
Mustafa Arkınel.
Yes, sir.
Mert Taner Salim.
Yes, sir.
Ekin Ejderoğlu.
Present, sir.
Muhammed El Bushra. Turki Huail.
Present.
Asem Ali Abd.
Present.
Amar Yasir Abdurrahman.
Yes, here, teacher.
Muhammed Al-Attas. Muhammed, not here. Didem Fatma Ateş.
Present, sir.
Ali Çetiner.
Here, sir.
Doğukan Birdal.
Here, sir.
Hüseyin Eren Mert.
Here.
Emre Özkaya.
Present, sir.
Sultan Akcansoy. Sultan, not here. Oyal Aktaşlı.
Yes, sir.
Okay. Mustafa Hacet.
Present, sir.
Birkan Uyar.
I'm here.
Mustafa Bolat.
Here, sir.
Ergül Amca.
Here, sir.
Kürşat Alkan.
Here, sir.
Okay. Sama Obadi.
Here, sir.
Muhammed Abu Soba. Muhammed Abu Soba, not here. It was Solene wrote to me. Yes, sir.
Yes, yes.
Solene was here.
Search is the girl who asked for.
Okay. I clicked on it. Hamza Otman.
Yes, sir.
Teacher, sorry, I am here, but you don't hear my voice.
What was your name?
My name is Sultan.
Can you repeat again?
Sultan, teacher.
Okay. I clicked.
Sir, I'm here also. But...
Al Mahdi Suwan.
Here, sir.
Who are you? Yeah.
Muhammad Habib.
Can you repeat again?
Muhammad Habib.
Muhammad Habib, but I read your name.
Yeah. 16, I guess.
Okay.
So even me, I had to change from my laptop to my phone. I'm on page. Yeah, I'm on number 38. Keith.
38. We didn't come to that yet.
38.
I didn't come to that yet. Moed Hamayun.
It's 30.
Yes, I'm here.
Okay. Muhammad Ibrahim El Fadul.
Here, sir.
Muhammad El Mozarahi.
Present, sir.
Abu Bakar Sahabi.
Yes, teacher.
Zakaria Al Fajuni.
Present.
Osama Baradem.
Yes, sir.
Muneba Ekitani.
Hello, sir. Do you hear me?
Yes.
I'm Muhammad Abu Soba. I'm here.
Muhammad what?
Abu Soba. Yes.
It was in the
27.
Okay. Muneba Ekitani.
Present, sir.
Kate Tanucci.
Yes, sir, I'm here.
Lantva Dilamani.
Present.
Prince Mitchell. No present. Ahmed Muhammad. Ahmed Nasar Aldin, not here. Salem Bashat.
Yes, sir.
Aliyu Yakubu.
Salim, yeah.
Salem,
42.
yes. Okay, I clicked on it. Aliyu Yakubu. Not present. Joseph El Said. Yusuf El Said. Not present. Sharef Al Sharif.
I'm here, teacher.
Merve Güneyhan.
Present.
Abdullah Karis.
Present.
Ray. Hoppa. 1 minute. I hope they are not gone. Abdullah Karis was here, right?
Present, yeah.
Raymond Stephen.
Present, sir.
Blessing Mac.
Present.
Abbas Faki.
Present, sir.
Obina Charles.
Present.
Hussein El Yassin.
Present, sir.
Ahmed Osman.
Present, sir.
Anas Alvarki.
Present, sir.
Muhammed Kais Alaba.
Yes, sir.
Hashim Alatra.
Present.
Bryce Lecky.
Present.
Osama Chaplut. Osama Chaplut, not here. Okay, the infest students. If I call your name, you can leave.
I'm sorry, someone's here. My mic is mute.
Mihriban Özdemir.
Sir, Mihriban has having electrical connection issues. She messaged me and your other account.
Okay then. Utku Yavaş. Not here. Grace Ojo. Grace. Not here.
I'm yes, sir.
Okay. Okay, I clicked you. Is there anyone who I didn't call their name?
Yes.
What is your name?
Osama. The last one.
What? Osama.
Osama.
Okay. Chapwood,
Yes.
right? Okay.
Yes.
So see you on Wednesday.
See you later,
All
sir.
right, sir.
Have a nice day.
Goodbye.
Bye bye. Please study well.